Every welder and engineer on a construction site faces the same question: how much electrode or wire do I actually need for this job? Get it wrong, and you're either running out mid-job, or wasting thousands on unused consumables sitting in the store. In this video, I'm going to show you the exact method we use on site to calculate fillet weld electrode and wire consumption, step by step, with real numbers. No complicated software, just a simple formula you can do on your phone or clipboard. Let's get into it. Before we calculate, let's quickly define what we're dealing with. A fillet weld is a triangular weld that joins two surfaces, usually at a right angle. The most important measurement is the leg size, also called the fillet size, usually noted as S on engineering drawings. This is what drives your consumable calculation. On your drawings, the fillet size might be written as 6 mm, 8 mm, 10 mm, or 12 mm, whatever the engineer has specified. And the length, that's simply the total run of weld you need to deposit. Could be 1 meter, could be 100 meters. We'll use that in our formula. Step 1 is to find the volume of weld metal. For an equal leg fillet weld, the formula is beautifully simple. V equals 0.5 multiplied by the leg size squared, multiplied by the weld length. This gives you the volume in cubic centimeters, assuming you enter the leg in centimeters and length in centimeters. One thing people get wrong here is the units. Let me be clear. If your leg size is 10 mm, that's 1 centimeter. If your weld length is 10 meters, that's 1000 centimeters. So for our example, V equals 0.5 times 1 squared times 1000. Wait, that doesn't match the image formula. Let me clarify. In the reference sheet, they use 10 mm as the leg directly, so the calculation gives 500 cubic centimeters. On camera, V equals 0.5 multiplied 10 squared multiplied 10 equals 500 cm. Keep your units consistent throughout. Step 2 is converting that volume into actual weight, because you buy welding consumables by the kilogram, not by volume. The formula is weight equals volume multiplied by density divided by deposition efficiency. The density of steel weld metal is a constant, 7.85 grams per cubic centimeter. But the efficiency? That depends on your welding process. Let me explain deposition efficiency. When you're welding, not all the electrode becomes weld metal. Some is lost as spatter, slag, and fumes. SMAW, stick welding, is the least efficient. Typically 60 to 65%. So for every kilogram of electrode you use, only about 570 grams actually ends up as weld metal. GMAW, MIG welding, is much more efficient. 95 to 99%. Less waste, less cleanup. FCAW, flux cord arc welding, sits in the middle. 80 to 85%. And so, submerged arc welding, is the most efficient at 99 excluding flux. Almost no loss. Using our example, volume is 500 cubic centimeters, density is 7.85 grams, let's calculate the weight for each process. Wo, SMAW at 60% efficiency, 500 times 7.85 divided by 0.60 equals 6.54 kilograms. Wo, GMAW at 94% gives us 4.17 kilograms. FCAW at 87%, 4.51 kilograms. And SOR at 99%, 3.96 kilograms. Now here's the real gold, the ready reckoner table. This shows you weld metal consumption in kilograms per meter for 4 common fillet sizes. For a 6 mm fillet with SMAW, you need about 0.6 kilograms per meter. For GMAW, it's only 0.13 kilograms per meter. Jump to a 10 mm fillet, SMAW needs 0.65 kilograms per meter, GMAW needs 0.42 kilograms per meter. This table alone can save you hours of calculation on site. Screenshot it, print it, pin it in your office. Let's work a quick example with the table. You have 50 meters of 10 mm fillet weld to do with GMAW. How much wire do you need? Wo, simple. 0.42 kg per meter, multiplied by 50 meters, equals 21 kilograms of wire. Done. That's your purchase order quantity. And finally, the quickest method of all. Thumb rules. These are simplified formulas that give you a fast estimate without needing the table. For SMAW, weight equals 0.0065 times leg size squared. For GMAW, 0.0042 times leg squared. 0.0048. SAW, 0.0041. So for a 10 mm fillet with GMAW, 0.0042 times 10 squared equals 0.42 kilograms. Exactly what the table shows. These thumb rules are perfect for a site walkthrough, a cost estimate meeting, or when your phone battery is dead and you just need a number. They're accurate enough for planning purposes. Always add 10 to 15% as a contingency buffer when placing your order. So let's bring it all together. You now have a complete, practical system for estimating fillet weld consumables on site. Step 1. Calculate the volume. Step 2. Calculate the weight using density and efficiency. Step 3. Use the ready reckoner table or thumb rules for speed. Whether you're doing a full material takeoff or just a quick sanity check, these methods work. If you found this useful, please like this video and subscribe. We publish simple, practical engineering notes every week. Download the free reference sheet at weldfabworld.com, link in the description. And leave a comment below. What size fillet welds are you working with most on your current project? I'd love to hear.